So today our goal is to be able to simplify an equation and isolate that variable. We want to get all of our variables on one side, and then we want to move our constants and our coefficients away from that variable. The variable has the flu. It tested positive for the flu. It needs to be alone. Okay, so we're looking to end up with 1x or k or whatever letter they give us on one side and then a value on the other. Okay, and we'll take that value and we'll plug it in and we'll check it. So we're going to look at some steps on how to do this. So we're going to always write our steps out in words, which doesn't always make the most sense, and then we will apply those steps to an actual problem so that we can make that connection. So our first step is going to be what we did yesterday. We need to make sure we distribute, and we don't have to do all of these steps each time. We need to distribute and or collect like terms. Sometimes we need to do both of those. Sometimes we only need to do one. Sometimes we don't need to do any. But that is the order in which we need to check. Distribute if there's a parentheses. Collect like terms on the same side. And then we are going to collect our variables on one side of the equal, right? So if we have letters on both sides, we need to make sure that we put all of our letters on the same side. And we do this by adding and subtracting. We will not multiply, divide to do this, okay? When you were in middle school and you learned about solving equations, what you do on one side, you have to do to the other, okay? So in this case, when we're moving letters, we're just going to add, subtract, and then we're going to move our constants, right? And we're going to move our constants to the opposite side of where our letters are. And again, we'll do that with adding and subtracting. Okay. Lastly, actually, I'm going to write one in here because it didn't do that. We're going to move our coefficient. Move our coefficient if we need to, and that's going to end up being a multiply, divide. And then last, we'll check our equation. Okay, I'm not sure why they left that one off. So this first example, notice step 1 is distribute, but we don't have any parentheses. So we don't actually need to do that. Do we need to, and if you want to draw the line, you can if you were taught that. Do we need to collect like terms? Do I have matching pieces on the same side of the equals? No, we don't. So we actually do not need to do that step. The next step, step 3, says move our variables to one side. Here's the thing I want you to think about. It doesn't matter which side you move the letters to. Okay, we can move the 11x to the right. We can move the negative 7x to the left. It will make your life easier as you get to those bottom steps if you move the smaller one. Okay, you do not have to move the smaller one, but it will make your life much easier. So if we think about this, we have 11x's and we have a negative 7x. Which of those is smaller? The negative 7. And remember, when we're doing that, we are adding and subtracting. So if that is a negative 7x, what is the opposite? So we're going to add 7x over here. And the goal in doing that is to eliminate those x's on that right-hand side. So a negative 7x and a positive 7x zeroes out. How many x's do I have on the left now?
18.
I have 18 x's. Bring down this minus 8 equals 64. Now it looks like a 7th grade equation or a 6th grade equation, right? Undo the add, subtract. We have to move that constant. What is the constant? Negative 8. How do we move it? We're going to add 8. 18x equals, what's 64 and 8? 72. Last step, undo the coefficient. What's the coefficient? 18. And it's multiplying a number next to a letter. This means multiply. So the opposite is divide. And like 95% of the time, that's going to be a division step. X equals, what is 72 divided by 18? 4. Are we done? No. You have to check it. When we check, we are going to put this 4 in place of the X and see if both sides are equal. Okay, and then I will show you how to check that in your yellow calculator. I will also show you how to check that on Desmos. That way, when you're at home, if you're doing this, you still have a method. So, if you're going to check this, we're saying 11 times 4 minus 8 equals negative 7 times 4 plus 64. And we want this to be true. All right, so for number 2, again, think about your steps. Step 1 is distributing. Do we have parentheses? Yes, so we need to start there. So we're going to distribute the positive 5. What do we get when we distribute positive 5? 10x minus 15. All right. Step 2, do we need to collect like terms? Do I have matching things on the same side of the equals? No, so we don't need to do that. Step 3, move our variables to one side. I forgot the x on my 10. Sorry. Tell me if I make a mistake, please. All right, so remember what I said. It doesn't matter which one you move, but if you move the smaller, you're probably not going to have to divide by a negative, okay, which can trick us sometimes. So which one is smaller, the negative 2 or the positive 10? The negative 2. How do I move that to the other side? We're going to add it. We're going to add it. So now, and it's okay to put your variable on the right-hand side. I know sometimes you're not used to that. We have 9. What is 10x plus 2x? 12x, good, minus the 15. Now it's a middle school question. Move our constant. What is the constant? The 15. What kind of 15? How do we move it?
Add the opposite.
We're going to add it. Add that opposite. 9 and 15 is what? 24 equals 12x. How do you undo the coefficient? Divide by 12. X equals 2. Are we done? No, you got to check it. Okay? If you don't want to rewrite this whole thing for a check, because we do have space in this box, you can come up here. You can say, I got to put the 2 there, and I got to put the 2 there, and then you can plug it into your calculator. Okay? All right, let's see what we got. We got to start with what? Step 1. We need to distribute. Let's see what we got. 5k plus, what's 5 times 14? 60? 70. And 1/5 of 20 is 4. Don't forget your k. And this is 16, yes? Negative 16. Make sure your sign, right? Positive times a negative is a negative. Do we need to collect like terms?
Yes, plus 16.
We do not need to collect like terms or when you have 2 k's or 2 constants on the same side.
No, we don't.
So we don't need to do that. So step 3 says move your variables. Which one is smaller? It's a positive 4k, so we're gonna subtract 4k. What is 5k minus 4k? We can put 1k, we can just put k, either one. Bring down your 70. Bring down, what am I bringing down right here? Good, don't forget that negative, it's important. Now it's a 6th grade problem. Move your constant, how do we do that? Minus 70. A negative 16 and a negative 70 is negative 86. We do not have to divide. We do not have to divide on this one because our coefficient is a 1. And if we divide by 1, we get the same thing. Now, let's talk about how to check it because that is going to be the piece that is super important. So, they didn't give us a box to check on this one, so I'm just going to write it up here. So, you're going to do 5 parentheses. We're saying K is negative 86 plus 14 equals 1/5. 20 times negative 86 minus 80. So that's what you're going to do when you check. So, what do you think the trick is on 5?
It's negative 2n.
The negative symbol
Add the
means,
opposite, so it'll still be,
no, what do we put right here? A 1.
Oh, you're right.
Right? We talked about that yesterday. When you have a negative in front of a parentheses, it is saying you need to multiply everything by a negative 1. Does that change your values?
Yes.
To what? Change it to a negative or it changes the sign, right? So, what do we actually get here? Negative and what? Plus. If you mess up on your sign, is it going to blow up your whole problem? Yeah, so please be careful. All right, what am I distributing on this right-hand side? Be careful.
-2.
The -2. Why not the 8? Yeah, it has to be right in front of the parentheses. This 8 is going to come down. Please do not distribute a 6, right? We're not doing anything with that 8 yet. So we have 8 minus 24. What's my sign on the next part? Plus, good. Plus 3n. Now, plus 6n, excuse me. Yes, you're right. I apologize. So that's a common mistake where people don't do that distributing, right? Like I just did. Yes, this is going to be our first example of that collecting like terms. They're on the same side of the equals. We can put them together. So on this left, we still have negative 8 plus 2n. What is 8 minus 24? Negative. Don't forget that sign. Negative 16. So, are we okay? That was our first example of that. Step 3, variables to one side. Which one do we want to move? The variables.
Oh, 2, 9.
The 2. Why do we want to move the 2? Because it's smaller. Make sure when you bring down that 8, you bring down the negative. Negative 16, what do we have? How many n's? Plus 4n. Now, middle school problem. Move your constant. What's your constant? The negative what? Negative 16. So we're going to add. Show me all the steps, right? 8 equals 4n. Last step. We got to divide. Are we dividing by the 4, okay? Because that's being multiplied. So n equals 2. Are we done? No, you got to check. Guys, it takes like 15, 20 seconds to check. Please don't miss these easy kinds of questions because you got lazy. Okay? So we would say negative parentheses. 8 minus 2 times 2 equals 8 minus 2, parentheses 12 minus 3 times 2. And you can put that in your calculator. So, this one on the left, what'd you do to solve it?
You have to distribute first.
We distributed, so we have 8x minus 16 equals 8x plus 3. And then what? Look at your steps. We've distributed.
First.
We don't need to collect like terms. Can we put our variables on one side? We're supposed to move the smaller, but what do you notice? They're the same. So look at what happens if I move my variables to one side. If I move, I say, okay, these are positive 8s, so I'm going to minus 8s. Look at what we get. We get negative 16 equals 3. Is that ever true? Does negative 16 ever equal 3? No. So this is never possible. This is going to be a no solution kind of question. If we look at the right, what do we need to do? We're going to distribute this. And we get negative 10x plus 16 equals, oh my, negative 10x plus 16. Well, these are identical. If I move my letters to the same side, right? Well, this is negative 10x, so I'm going to add it. Because that's the opposite, right? Not. Oh, but does 16 equal 16? Ever? Always, yes. This is always. So this means this is always true. So we're going to look at, there are actually, when you solve an equation, y'all are used to getting one solution, right? X equals 2, x equals negative 8, whatever. There are actually other solutions to equations. So let's have a glance at that real quick. So we can have, so when we have equations, we have three types of solutions. We can have one solution. Well, this is what you're used to. You only have one value that makes the equation true, like x equals 2, like we had a minute ago. We can have infinite solutions. Actually, I did that one backwards. This one is not infinite. This one is no solution. My bad. I didn't read the description. My fault. This is no solution. There is not a value that will make the equation true. So like we had up there a minute ago, right? Negative 16 equals 3. Well, that's never, ever, ever a possibility. Never. Then we can have all real numbers, where you can have any real number, any number will make the equation true. This has infinite solutions. Okay, so on the one we just did a minute ago, 16 equals 16 always. That means that when I look at this equation up here, I can put any number in for x. I could put 0 in for x, and I will get the same value on each side every single time. I could put in a positive number, I could put in a negative number, I could put in a fraction, I could put in a decimal, I can do all of those things, and it is always going to be equal on both sides. Okay? So, does that make sense? Do you want to do any examples of that?
No.
We're good.
All right, let's look down here. A couple of word problems, and then we will move on from there, okay? We did a perimeter problem yesterday, so what I want to focus on right now is just setting up the equation, because I think you guys are pretty good at solving it, okay? So if Gil traveled 4.5 miles and continues at a speed of 62.5 miles per hour, look at for your keywords.
Per hour.
Per means what? X, good. Andy has traveled 29.5 miles and continues at a speed of 50 miles per hour. If the cars continue at the same speed, how many hours will it take them to travel? Right here, same. What does same mean? Equal. All right, so what does this look like? Let's do this. What does Gil's expression look like, and what does Andy's expression look like? Gil looks like what? 62.5x. But what about this has traveled this much already? There you go. Plus 4.5 equals, what about Andy? 29.5x plus? Nope, no x? Why no x on that one?
Because it doesn't say per hour.
Yeah, that's where they started. And then?
Plus 50x.
Plus the 50x. Very nice. We talked about perimeter yesterday. So the perimeter of the triangle and the perimeter of the square are the same. We just said same means equal. How are we going to do this?
So the one on the left, there's 4 sides, so you do like one.
Can
I
we?
meant the one on the right. So the one on the right has 4 sides. So you put it in parentheses and then put a 4 in front of parentheses.
Very nice. All right, so this one, because it's a square, all the sides are the same. We can say 4 times 6.5x minus 11.8. We can do that.
And then the other side, you would do, you do 5x negative 1. You multiply that by 2, right?
We can, yep, we have two 5x minus
And
1s.
then plus the 2.2x plus 10. And then the equal sign in the middle. And they
Very nice. And then you can solve it, yes? You would have to distribute on both sides.